All right, it's late, 9 o'clock. I'm going to be thorough, but I'm going to try to knock these out quickly while also communicating effectively. So number 1 and number 2 are super easy. You have the answer key, you can look it up. Atticus could do this. I mean, it's no big deal. Same with 3 and 4. I feel like multiplying, you guys should be able to do that. That's not an issue. These are kind of gimme points, right? Atticus can also do this. I trained him already. However, number 5. Number 5 is division, but this is a monomial. You can only use synthetic division and long division. Now, long division I clipped from the final. But synthetic division and long division are used using binomials, all right? But long division can actually be used for trinomials and polynomials with 4 terms, but that is so rare that it's really just like it's unnecessary. But with monomials, you have to use a different strategy because you cannot use synthetic division. First of all, because you would have to put 0 in the window, and putting 0 in the window doesn't make too much sense, right? Because it's not going to work. So the way we do it is we take each one of the terms, okay, that we're dividing into, and what we do is we put a fraction bar over each one of these guys, all right, and then we simplify them. We simplify them as if they were individual terms, right? Which is what they are. There's 3 individual terms. We want to simplify them based on their exponents, their variables, common factors, etc. So 6 will go into this guy 5 times, all right? But then x to the third and x to the third, with them over each other, it's just 1, so those guys technically cancel out. So we are just left with 5. So you actually, you can see your answer is B. All right, but how do we arrive to the rest of them? Because tomorrow's exam will be tougher, right? So we arrive to the rest of them with 6 will go into 12 twice, but there's 2 x's on the top, 3 on the bottom, so therefore these guys will be absorbed by 2 on the bottom, and there will be 1 left on the bottom. So that would be 2 over x, and then finally the same thing, 6 will go into 12 twice, but this will be absorbed by 1 of the 3 that are in the denominator, so we will just get 2 over x to the second. All right, and that would be your final answer. There's no equal sign. There's nothing. You're just dividing a polynomial of whatever degree by a monomial. You just have to take the monomial, put it under each one. So over here, same principle applies, same technique. Okay, because there's synthetic division. It's like, well, what do I put in the window? So hopefully you would understand that, oh, this is the situation where I have to do something different. Okay, we do this all the time in calculus, all the time. So the 10s cancel out, and I have 1 left in the numerator because those 2 get absorbed to the top. So I have just 1x. Here I have a 2 that will go into both, so that would be 2/5. And those cancel out, so that's that. And then 4 will be on the top, and 1 will be left on the bottom, so 4 over x, and you can see that that's C. Okay? So it's just pretty much taking this binomial, putting it under each term, and just canceling term by term. All right, term by term. All right? Now when you get to the other division, this right here is dealing with synthetic division. All right? So what I'm seeing here is I'm dividing this cubic polynomial by a binomial, a linear binomial. And he's linear because he's k to the first. So this means that I will use synthetic division. So I always put the opposite sign here. Okay? So I will put the opposite sign here. And we're going to label the coefficients 1, 3, -47, and 53. Now there are no terms with k that are missing an exponent, like 3, 2, 1, 0. So it's all in order. There's no omissions. Just like in number 8, that's going to be the same thing. If you are missing one of those terms, all right, like let's say that was missing and you just had a k to the third, minus 47k, we will have to put a 0 there, but that's not easy to spot all the time. All right. So synthetic division, 1, -9. that will be negative 6, that will be 54, that will be 7, and then that will be negative 63. So then that ends up being negative 10. So what does this mean? It means that when I took this cubic and I divided by a linear binomial, I had a k to the third being divided by a k. So the result would be a k to the second. And that's exactly what this is. All right? This is a 1k to the second minus a 6k plus a 7 nothing and then a minus 10 remainder. So I put that k plus 9 right there. Okay? And we can see this reflected in this guy right here. Yes, it's C. Okay, same thing here. You're going to have a negative 2 in the window. You're going to have a 1, negative 2, negative 12, negative 14, no zeros. Okay, 3, 2, 1, 0. So there's not going to be a 0 for a coefficient here. We drop these guys clean. Negative 2, that's negative 4, that's positive 8. Negative 4, that's positive 8. Negative 6. And I did that wrong because I did it too fast. No, I did do it right. Okay, because I looked down here, I didn't see the answer, so I was like, oh, went too fast. So this is m to the third. He drops to an m to the second. So here, minus 4, minus 4, minus 6, minus 4, minus 4, minus 6. All right, so the answer is A. All right, that shouldn't be too hard for you. All right, we'll do 9. We'll actually go up to 12, and we'll stop. So, is something a factor? Well, if something was a factor, then this remainder would never happen because it goes in cleanly. All right. Now, there's super huge benefits to that, and not having a remainder in calculus. So we want to make sure that we can take this guy, divide it into here, and if it's clean, it's great. All right. So what we do is we do the same strategy, but it's just asked in a different way. All right. So you have to remember what's needed for a binomial to be a factor, and it's the fact that the remainder is going to be 0 when you synthetically divide. So 8, negative 3, negative 45, positive 42. Got 8, drop the 8. Okay, that's 32. That is 9, negative 9, negative 36. I feel like that got out of control pretty quick. 32, is that negative 9? Yeah, I was right. Negative 36, negative 81, and then, yeah, that's too large. So the answer is no. Okay, so that would be B. All right, there's no remainder of 0. But over here, if I had negative 8 put in the window, and that's 1, 11, 27, 24, let's see what happens. 1, negative 8, 3, negative 24, 3, negative 24, that's a yes. The remainder is 0. Now, I don't even care what's there, all right, because it's just asking state whether it is. So we're going to go ahead and give that a yes, all right? Now, here's where it's a little different, and this can kind of pose you can like go and look at your answer and, think that you did something wrong. But in this case, you are not going to switch the sign here, okay? Because what you're asking up here is you are asking, does this divide evenly? All right, so a root would mean when does k plus 9 equal 0? And the answer is at negative 9. Where does m plus 2 equal 0? And the answer is negative 2. So at negative 2, do I get a 0? At negative 9, do I get a 0? Like, does it actually hit the x-axis? This is saying, well, at negative 3, I want to know where do I land. Does it equal 0? It doesn't matter in this question because it's asking you to evaluate what does it equal once we put it in. All right. So I'm not sure if that explanation is actually helpful for you, but we have a 6, 4. Oh, we're missing a 5. 4, 3, 2, 1, 5, 0. Okay. So we need a 1, a 0 for the 5. Okay, for the 5th degree term. We have a negative 5, a 14, a 4, negative 8, and a 5. All right, so we got a long one, but as long as you're careful, your answer will show up. 1, negative 3, positive 9, positive 4, negative 12, positive 2, negative 6, negative 2, positive 6, negative 2, positive 6, 11. So the answer is 11 because that's your remainder. All right, now you can slow this down and do it at like 0.25 timing to catch all that, but it's basic math. All right, it's like counting cards. All right, so for 12, again, we're just going to put 6 in the window exactly as he is because we're evaluating it at that number. Up here, we're asking a different type of question. I want to know, does -8 hit the x-axis? And so that's what this is saying. All right, so 5, 4, 3, nope, we're missing the 2, so look out for that because that's definitely going to happen in your exam in both of these. Okay, so if you're watching this video, heads up, it's going to happen in both of them. So 1, -9, 17, 0, 33, and 21. Okay, so now we're going to, slow this down because I'm going to go fast. 1, 6, -3, -18, 1, 6, 6, 30, -1, 3. Went a little too fast there. Okay, your answer is 3. So remember, this is called the remainder theorem. Okay, and this is no theorem at all. It's just synthetic division. All right.